The following is Spring 2010 Math 1 of Department Final. In this video, I will do number 6, 7, 8, 9, and 10. Number 6. Add or subtract, the answer should be a mixed number in correct form. Number 6. 13 1/7 minus 8 3/7 equals to, let's see, notice that the fractional part here is not enough to pay the fractional part there, so we need to do some borrowing, right? We borrow 1 unit from this 13. Okay, maybe I put it here, 13 1/7. If I borrow 1 unit from 13, it becomes 12, and then that one that I borrow, I stick it together with the fractional part, and then I change that becomes improper fractions. That's 8/7. Okay, so then this becomes 12 8/7 minus 8 3/7. That will be 4 5/7. Okay, then if we see, the answer will be C. Now that's one way. Some people don't get used to do it this way. Some people say, okay, I will change it to improper fraction. That is acceptable, especially because this is multiple choice, so nobody really care about how you show the word, right? But if you make it into improper fraction, let's redo the question. If you do it in improper fraction, then this will be 13 times 7, that's 91, plus 1, that's 92/7, minus 8 times 7, 56, plus 3, 59/7. When we subtract, if you subtract that, I think you will get 33. Yeah, 33/7, which if we change that into mixed number, that will be 7 goes to 33 4 times, and the remainder is 5, becomes 5/7, right? Let me do it here. 33 divided by 7 is 4 times, for 28, the remainder is 5, right? Now that's for number 6. You can do it this way, you can do it that way, either way. Now of course, in my class I teach this way, but some teachers, especially because the denominator is not a big number, it is acceptable to do it that way. Number 7. Evaluate b squared minus 4ac for the b equals to -5. Let me fold this so that it doesn't confuse you. And the a is 3, the c is 6. Now if I plug in the numbers, then I will get -5 quantity squared. Don't forget that parentheses. You are squaring the b, which is -5. Without parentheses, you are squaring the 5 only. Okay, let me continue. Minus 4 times a times c. Maybe we put it this way. Every time you replace a variable with a negative number, you want to use parentheses. Okay, keep that in mind that way. Now then from here, let me follow order operations, which means I will need to do the exponent first. That will be 25 minus 4 times 3 times 6. And then subtraction, multiplication comes first. There will be 25 minus 12 times 6. Still the same thing, right? 25 minus 12 times 6. 12 times 6 is 72. So this will be negative, what's that? 47? Negative 47 now. How do I get it? It's basically negative first, right? And then you subtract 72 by 25. Then I subtract, I do borrowing. This is 12 here, this is 6 here. So you get 47 when you subtract. Of course, you need to put the negative. Okay, therefore the answer is C. Okay, now that's for number 7. Number 8. Number 8. Decide whether the following is an expression or an equation. Okay, an expression, at least at this level, is the sum of terms. Okay, maybe negative terms, therefore it looks like negative, and it has some negatives, right? But equation, one of the big mark of an equation, it has a variable, it has an equal sign. An equation, one of the sign is it has equal sign in between. Okay, so if you see x squared plus 19xy minus 5, okay, we don't have equal sign, so this would be expression. If it is not equation, then maybe we need to check if it is expression. And how do we confirm that this is an expression? You see that this is the sum of terms. Okay, x squared, 19xy, and negative 5. Okay, so first, it is yes an expression. Second, it is not an equation. Now you may wonder, Thomas, is it possible that it is both? The answer is no. It won't be both. Okay, it won't be an expression and equation at the same time. Okay, at least we are not at that level yet. I'm not aware of any cases in math in which you have something that is an expression and also an equation at the same time. Okay, is it possible to be neither? Honestly, I don't know, but I don't really remember having a case in which, at this level, in which that it is not an expression and nor an equation. Okay, yeah, so it's either or in this case. These two options just to distract you. Okay, yeah, that's for number 8. It is an expression. Okay, now let's see number 9. Number 9, we will solve this equation. 61 equals to 9x minus 2. You see, this is an equation because you have equal sign between. And usually, if you have an equation, the question they ask you to do is to solve it. Okay? Expression, you simplify. Equation, you solve. Okay? Now, let's start. How to solve this? Well, I need to undo the subtraction by 2 first, and then undo the multiplication by 9, right? So I will do 61 plus 2 equals to 9x. It is 63 equals to 9x, right? And then you divide by 9 on the other side. That will be 7 equals to x, right? So the answer is C. Okay, now some teachers, very likely yours, also like that, do not show the work this way, and I think it's reasonable. This is minus 2 if you do it this way, even though in my class I don't teach this way, but I show it here just in case that's how you were taught. This subtraction, to undo the subtraction by 2, you add both sides by 2, then you get 63 equals to 9x, and then you divide by 9 both sides, then you get 7 equals to x. Okay, now some students learn it that way. Because this is a multiple choice, then I show it to you anyway that it is doable that way if you like, and you still come up with the same answer. The answer is C. Okay, number 10. Let me fold this. Translate to an equation, then solve. Number 10. 4 more than a number is equal to 15. 4 more than a number is equal to 15. Okay. Oh, seems like they use n instead. Let me change this to n. Let me change this to n. Let me change it to n. 4 plus n equals to 15. Now then, which one match this? Both of them are the same here, right? The addition is commutative, so either one can be okay. Even though my expression, my equation match with part B, but part D actually another way to do it, right? Okay, now let's solve with this. You subtract by 4 both sides. N equals to 15 minus 4, so n equals to 11, right? So from here you see both of these equations are the same, right? Only the order of addition is different, but when you come to the solution, you see that the first, in part B, the solution is not correct. Is it right? 4 plus negative 11, definitely not 15, right? Okay, now in part D, 11 plus 4 gives you that 15, that much, this one instead. Okay, so this will be part D here. Okay, now this is from spring 2010, Math 112 Department Final, number 6 to number 10.